This Raw Green episode is brought to you by Obi, a sustainability consultancy firm specialized in life cycle assessment and decarbonization strategies. For more information, check oneobi.com or visit our page on social media. Links in the description. Welcome to another episode of Raw Green. Today, it is my immense pleasure to have as a guest Martin Zhu. Ciao, Martin. How are you?
How are you? Yeah, fine.
Good, good. Martin is the co-founder and one of the inventors of I2Cool. I2Cool, it is a, can we still call it a startup? A
Yeah, definitely. We are.
Yeah, can we still call it a startup? It is a fantastic venture based in Hong Kong that developed a new technology based on the passive radiative cooling. We'll get into that, but before this, Martin, I gotta ask you two things. The first one, lower your
Yeah.
camera. The second, it is give us an
Oh, sorry, the
introduction.
camera.
Give us an
Yeah.
introduction of your studies. I want to know about
Mm,
your PhD. And
mm,
we're both alumni of the School of Energy and Environment at CTU. I had personally a wonderful experience at the SCE. The professors were
great.
just phenomenal, all of them. Study
Yeah,
wise,
great to hear that.
it has been fantastic. Yes, all of them.
Mm,
So I'll shut the hell up. uh, Give us a little bit of a story about yourself and your studies.
yeah, yeah. Thank you, Francesco, for inviting me to share my story. Yeah, my name is Martin. I studied my PhD degree in energy and environment at the City University of Hong Kong. My study was focusing on the building energy sectors. Like, in Hong Kong, it's quite a humid and a hot city that we
Mm,
need to consume a lot of energy for air cooling because of the hot climate. And in Hong Kong, there are around 30% of the electricity in buildings was consumed by the AC system, which is the major sector that we can reduce the energy cost and to promote the overall carbon neutrality for the city. I mean, most efficiently because this proportion is the biggest one. And that's why the study in my PhD degree was focusing on the building energy saving, especially for the air conditioning systems. And in this system, there are a few different methods to cut the energy consumption. And the first one is that we can reduce the cooling load of the system. Reducing the cooling load, we can equip the whole buildings with some special materials in the envelope to keep its building cool and reduce the cooling load. And the method our research team figured out was the passive radiated cooling materials on the envelope of the buildings. That's why during the 4 year study of my PhD degree in CTU, me and the research team and my PhD supervisor, Professor Alvin Cho, we focus on, upgrading the technology for the building envelope using the passive radiated cooling materials. Because at the beginning, this technology was quite expensive, we need to use some heavy metal like silver to create a structure
oh
that
wow.
can uh,
Mm.
achieve the cooling performance. But nowadays, we can use some inexpensive materials such as polymer and nanoparticles with optimized optical structure that can achieve an excellent optical performance. And the inspiration of this invention was actually from and Sahara silver ant. And since
From
2015, our
ants.
research team,
The inspiration
yeah,
comes from
ant, Sahara
ants.
silver.
Okay, this is a
Yes,
particular kind of
Sahara silver ant.
ant, silver ant. Okay, go on. This is
Yes,
interesting.
silver ant. yeah, silver ant in Sahara Desert.
In the
And
Sahara
since
Desert. Okay.
2015, our research team studied the ant. This because this ant is very interesting. It can survive in the hot desert because of the self-cooling structure on the skin. And then we studied the ant, and we figured out that it can reflect most of the sunlight to prevent the body from being heated by the sun. And in the meanwhile, it can convert its body energy into mid-infrared wavelength, which is 8 to 30 micron. This wavelength can just pass through the atmospheric window and be absorbed by the universe, so that the cooling power can be generated on the surface of the ant. And then we adopt this cooling principle into our materials that we can learn from the optical properties, such as the light scattering efficiency of the ant structure. And then we put this light scattering principle into the building materials that can achieve similar functions and in a cheap way, not expensive, but we just optimize the optical structure of the nanoparticles and then add these particles into the normal building materials. This is the overall picture of our technology. We apply these materials to the buildings at the beginning, and we found that it can reduce like more than 40 degrees C on the surface temperature and more than 10 degrees C for the indoor air
Hold on.
temperature, depending on the
Slow down.
structure of the buildings.
Slow down.
Yeah,
You said 40 degrees.
yeah, 40 degrees C.
40
Degrees C.
degrees Celsius. That is a
Yeah,
lot, Martin.
yes,
So from a
yeah,
surface that has your tech on top compared
yeah,
to the
yeah,
same surface next that hasn't,
yes,
there can be
yeah,
40 degrees difference. Okay, that's huge.
yes,
That's huge. Massive. Sorry,
yeah.
go on.
Yeah, because the surface temperature is reduced, and then we can reduce the cooling load of the building with the reduced surface temperature. Because with the conduction between the surface and the indoor environment, the indoor air temperature can be reduced. And when
Yeah,
you have a lower indoor temperature, the cooling load of your AC system
will be reduced.
is
Yes.
reduced as well.
Yeah,
Yeah, it's
yeah,
reduced as well.
yeah.
We can cut the energy cost by around 20 to 40%, depending on the structure of your buildings.
That's
Yeah,
massive. That's massive.
that's why we can reduce the electricity cost and reduce the carbon emission, because you generate electricity with carbon emissions. That's why
Hmm.
the carbon emissions can be reduced because you use less energy. Uh,
Yeah,
in the long
that
run,
depends.
we will also be
That depends
yeah
on the grid intensity, obviously. And Hong Kong,
yeah yeah
actually,
yeah.
it is not too bad. The grid intensity, because
Oh, it's okay. Hong Kong is
uh,
okay.
a good chunk of the energy comes from the nuclear power plant in Daya Bay, if I recall properly.
Yeah,
But
yeah,
there is still coal and gas going on between the Lama
correct.
production and others that comes from mainland. But all in
Yeah,
all, it is not the worst. There are some countries that they have over 700 grams of CO2 emissions per kilowatt hour in the grid. Uh, but
yeah,
I wanted to
correct.
ask you about the materials. Okay, you said
Mhm.
that it started with silver, which obviously it is an expensive material. Uh,
Correct.
what kind? Now you don't have to tell me the formula, obviously, but what
Ah,
kind of materials do you use, and what is the carbon intensity of those materials that you use? Have you factored that into your calculations? The sourcing, the procurement,
yeah.
the supply chains of those materials.
Yeah, and actually, we didn't use some new chemicals into the paint
Mm,
or some other building materials, but we just changed the structure of the materials inside. For example, for the normal paint or traditional paint for buildings, it is composite with organic emulsion, which is liquid,
okay.
and also some functional particles, which is inorganic. For example, the color pigments and also the pigments for sunlight reflection, this and that. For the traditional paint, they use this kind of materials. And same as us, because we chemically didn't change the formula, but we just optimized the nanostructure mechanically and physically, use the nanostructure to have a very excellent optical material. So uh, I mean, from the raw material side, we didn't increase the carbon emission
Mm,
because chemically they are the same, but just with different, I mean, in different structure. That's why what we do is to add a little bit of the mechanical processing
okay.
to the nanoparticles. But for some conventional materials that they also need the nanoparticles, but they just like they don't have the optical failure to optimize the structure, so they just add the structure that they can find from the market. That's why what we add is actually is basically just a very simple mechanical processing that
Okay.
we can well quantify by the electricity
Consumption. Yeah.
cost in the factory.
Yeah.
Yeah, yeah,
Yeah.
yeah. And for the material supply, raw material, logistics, supply chain, I think more than 90% of the life cycle of the product
Mm,
are quite similar to the normal or conventional materials. Like for example, if the buildings, uh, it is a must for most of the buildings to apply with the envelope materials, right? Like
mm,
for the normal building, they need to apply the paint for waterproof or dustproof or whatever,
mhm.
or appearance issue, whatever. And then in this situation, if they change the normal material with our materials, then uh, they probably won't have a very significant change in the carbon emission because we didn't add too much of the new phase into our materials. And then they can achieve a very significant energy saving because they use less energy in the air
Of
conditioning
course.
system. That's why the carbon emission is negative. I mean, net negative
Let me do
to the
just
user.
on top of my head do some rough calculations. Okay.
Mhm.
So
Yeah.
let's say that I did a while ago a very quick research on the carbon footprints of normal commercial paints. Okay. And if I
Mm.
remember
Mm.
correctly, we're talking about something between it is very broad, 3 to 10 kg of CO2 emissions per kilo of product. Okay. And this
Yeah.
is
Yeah.
cradle to gate. If
Mhm.
let's say you have to use I2Cool paint,
Yeah.
you're
Mhm.
able with the 1 liter you cover what 10 square meters of space roughly. It depends obviously on the
Uh,
surface, I imagine. uh,
yeah. Yeah. Yeah.
but you with that 1 square meters, basically, if you have a carbon intensity of 500 grams per kilowatt hour, it means that to offset three to offset 3 kilos, it will take roughly 500 grams, around six
Yeah.
kilowatt hours. You
Yeah.
have to save 6 kilowatt hours of
Yeah.
energy, basically, which is totally doable if you
Uh,
say that you can save 20%.
yeah. Yeah, yeah, yeah. And basically, based on our observation from our previous project, each square meter of our materials can reduce more than 120 kilogram carbon emission each year.
Wow.
So, like the durability of our materials is 10 year. So I mean the life cycle of our materials, each square meter can reduce 1,200 kilogram of the
Wow.
carbon emission, which is
That's amazing.
way larger than the
That's
production.
amazing.
Yeah.
And you tested this in the Hong Kong environment, which is very adverse to any building material due to the humidity, torrential rains, and temperature, obviously.
Mm.
So 10 years of Hong Kong, it
Yeah,
is 15,
yeah, it's based
20
in Hong
years,
Kong.
yeah, somewhere else. Yeah, yeah, that's
Yeah, yeah, yeah.
incredible.
But if you apply to some other locations like the Middle East, that is quite dry and even hotter,
Mhm.
this number is even greater. Yeah,
Yeah, it become greater, right?
yeah.
Fantastic, fantastic. Sorry, let me ask you something else. So, let's jump back in. You finish your studies, you finish your PhD, and you set up together with the other researchers, I2Cool. Okay, while you were finishing your PhD, is that correct?
Yeah. My PhD was finished in August 2022,
Okay,
last year,
last year,
and
yeah.
then and then I started the company operation. I mean, the founding and the company operation in September of 2022, right after my
Okay,
graduation.
okay,
And we have another two co-founders. They are my PhD supervisor and the
okay.
supervisor of my supervisor. So we have three
Wow, three
co-founders. Yeah,
generations.
and I'm the only. Yeah, three
You got three
generations, correct.
generations of
And
researchers.
yeah, fifth generations exactly. And I'm the only one that is working full time in the company because the other two are professors in the university. So
Mm,
their full time job is still based in the university to keep providing a new input of the research for our new product in the future. Like we are not just doing the paint, we can also do the film for the glass windows and nowadays,
okay.
we just published our research on science about our cooling ceramic last month, and then this will also be one of our new product in the future. Yeah.
Well, we will put the link of the research in the podcast description for everybody that's listening
Ah,
and
thank
it
you.
is interested. Well, it is fascinating stuff. I mean, my nerd parts comes out very violently right now, and I want to read that. I want to read that research. All right.
Thank
So
you.
now you set up the company, and then obviously you start your life on the road, pushing I2Cool products, technology, and solutions. Okay, so I
Yes.
obviously follow you on LinkedIn. I see that
Wow. Thanks. You are
you
my fans,
spend
man.
no problem, dear. That you spend lots of time on the road. I've seen you that you were also at COP28. Now, how
Yes.
was it? And before you tell me how was it, I tell you what I think from the outside. Um, it was good, but every year that I follow COP, I have the impression that it is turning into more of a climate expo rather than a solution, uh, rather than a solution making or decision making place. Nothing wrong with the climate expo
Yeah.
because you need a million startups like yours, okay, to be able to tackle the challenges that we have in front of us. On the other hand, you also need those big guys to be able to take uh, very important decisions. Very important decisions. So,
Yes,
how
correct.
was it?
Definitely.
You were in the green zone, right? With
Yeah, the
the
public one.
I2Cool, yes. And how was it? Tell me.
I think it was quite amazing because we can meet with a lot of different people, especially for those from the government officials in different countries. Like I met a few mayors of the cities in the Europe, and I also met with some government officials in UAE. Because, as you said, a startup company is the solution provider to tackle the problems of
Yes,
climate change.
yes,
But we also need the big guys from the government, for example, the decision maker, to provide a good environment or a good policy to adopt the new and the green technology to their home
yes,
country.
yes,
And yeah, and this way we connect with them and yeah, we can understand more about the situations in different countries or different cities. Because our technology was invented in Hong Kong, we lowering we know the situation of Hong Kong very well. That's why we can adopt our cooling technology into the Hong Kong market quite good. But for the other countries or other locations that we haven't been there before, and then we may not be able to understand the market very well. And I think the COP28 is a platform for us to connect with those people from different markets that we can understand a little bit better, at least a little bit better than ourselves.
Sure.
So we can connect with different people, but not just the government side, because in the blue zone, there is another zone next to the green zone in the Club 28. The green zone is for the public, like the startup company to showcase the technology. The blue zone is for the government officials to discuss the policy or the future direction of the global climate collaboration. And for the blue zone, they're actually not just the government officials. There's still some very big company. I mean, the head of industrial leaders that can go inside and then discuss with the government officials. And from the blue zone, people will just walk inside the green zone and talk to the company. That's why I can talk to some government officials, as I said. And I can also meet with some big companies that are interested in the sustainability. Because for those big companies going into the COP28, they probably have something to say and something to talk to the government officials about their point of views in sustainability. It means
Mm.
that they are the nature that have a very strong concern in the sustainability and the global warming and climate change issues. And for those companies, they have a lot of different industries that are quite diverse. For example, I met developers in Turkey and also
Mm.
a logistic company that has a global operation, and then it is based in the US, but their operation is in the Gulf. And they have a very strong list of the technology to improve their conditions. Like for the company doing logistics, they may
Mm-hmm.
ship some materials that need to be kept in a low temperature, like the medicine and also the vaccines,
Mm-hmm.
etc. And then if we apply the cooling materials on the surface of their containers or their facilities, we can improve the storage condition or reduce the cost of the energy in keeping
Yeah.
the materials in a low temperature during the transportation. Yeah, this is
Yeah.
another angle. And we found some new angles from the COP28 because before going there, we couldn't imagine that the technology can be applied in such a lot of different applications. Yeah,
Applications.
but
Yes.
going there, we can explore some new applications and new directions for us to fine tune the technology.
Solar modules too. Sorry, solar PV modules on the
Yeah,
structures of the PV modules,
yeah,
right?
PV
That
modules.
helps keep the temperature
Yeah,
low and reduce the energy losses.
yeah. This is one of our case we did in Hong Kong that applying our
Okay,
materials to dissipate the heat generated during the conversion. Yeah, that
fantastic.
can improve the generation. There's
What
another
do you
one.
have? Do you have
Well,
numbers of this test on the solar modules?
yeah.
How was
On
it?
the Hong Kong's climate, it is around 3 to 8% improvement in generation.
Wow, that's a lot.
Yeah, that's a very significant number.
3 to 8% just by reducing the energy dissipation from heat.
Yeah, just reduce the temperature to improve the efficiency. Because for that material,
Fantastic.
they have an optimal point, which is around 20 to 30 degrees C generally. Once the temperature increased by 1 degree C, the efficiency will drop by around 0.4 to 0.5%. That's why when we reduce the temperature, the efficiency can be improved.
Wow. That's amazing, Martin. And you were saying
Yeah.
before that the other you and the other two co-founders are working on also other applications of the passive radiative cooling technology methodology on film for Windows.
Yes.
So,
Yes.
and how does it work? Because that it cannot be white and
Yeah,
reflect
cannot
back
be
the
white.
light. So how does that work?
Yeah. Yeah, because the cooling principle of our technology is not just the reflection. Reflection is just to isolate the heat from outside.
Mm.
For the glass window, we focus on like absorbing the internal thermal energy of the indoor environment and convert into mid-infrared for heat dissipation. So we focus on the emission part for the glass film. That's why we can keep the transparency of the materials that can be applied to the windows. We can keep the visible light transparency to be more than 85%. So it's not quite different when you apply to the windows. And the application
Wow.
is quite easy. You can just use the water to spray on the windows and then attach the film and use a small tool to scratch the water out. This is very similar to the
What
normal
do you do
heat
on the
reflective
car?
film you
Like you
can
taint when you
find.
taint the glass of the car. Same
Yeah,
concept.
yeah, sure. Yeah, sure. Yeah, in Hong Kong, we actually did a case with City Bus. We applied the glass film to the buses, to
Mm.
the windows of the buses, and also applied our paint to the rooftop of the bus. And the internal temperature, the indoor air temperature of the bus can be reduced by around 4.6 degrees C. It's very
Wow.
significant. It can
It is.
improve the indoor thermal comfort of the passengers inside.
Yeah, reduce consumption of the AC in the buses. Again, you go towards that
Yeah, also
high
reduce
level
as
of
well. Yeah,
efficiency. Yeah. And
yeah.
what is right now your biggest market? Where you have
Uh,
the biggest projects and clients and interest too?
Yeah, actually, the 2023 is our first year of commercialization because
Mm-hmm.
we started the company at the end of last year. This year, we got like 70% of our revenue in Hong Kong with Meng because
Okay.
Hong Kong is our home area. Yeah, we have most of the connections here. Um, in Hong Kong, Hong Kong has a lot of buildings. So the building sector is one of the biggest sectors uh,
Yeah.
we are doing in Hong Kong. And the remaining are like the outdoor devices, like the 5G base station, the converter in the outdoor environment, and also the data center, and also the
Mm-hmm.
energy storage systems. That is also a kind of electrical devices that can be applied with our technology to improve the efficiency.
Yeah.
And the other one is the logistics supply chain and also the vehicles like the city bus and also some other buses or other vehicles that are for transportation something for transporting something that is sensitive to the heat. Yeah, we mainly apply to this area. And the remaining 30% are from mainland China, Southeast Asia, and even the Middle East. We have done a project in Emaar, Dubai Mall.
Oh wow.
Apply on the roof to reduce the energy cost of the AC. And we also did a case in Abu Dhabi, collaborating with the Emirates Palace to showcase the technology. Yeah, so now we are actually expanding outside Hong Kong because our cooling technology can perform the best in the tropical area based on our Energy Plus simulation. When the temperature, or the weather is hotter, or the humidity is lower, the performance will be better. So the
Mm-hmm.
Middle East is actually the best place
Yeah.
for us to showcase the technology. Yeah,
Yeah, yeah, where you have that incredible numbers of 40 degrees difference that we were talking at the beginning,
yeah,
right? Yeah, those but
yeah,
those are extreme conditions too. Think about
yeah. In
markets like,
summer and the
yeah,
lunes.
center of or north Europe, okay,
Yeah, Lune
or
and
like
Lune. Yeah.
Italy, for example, or others. Definitely in
Um,
the logistic part, there is a lot to do, not just for the storage side, but the transportation part.
mhm.
Imagine the cold chain, the help
Yeah.
that it could give to be able to have more efficiency, not just on one truck, but imagine on a fleet of 1,000 trucks, what those numbers can
Correct.
be at the end of the year for the fleet managers in terms of savings. Those are pretty big
Definitely.
numbers. pretty big numbers. And
Yeah.
what
Mm-hmm.
about the China market in the specific? When you hear about
Mm-hmm.
China and climate change, or let's say future developments, the first thing that comes out, it is the staggering amount of new developments in renewables that China it
Yes.
is doing, both
Mm-hmm.
solar and wind. But when it comes to energy
Mm-hmm.
efficiency technology, you don't
Mm-hmm.
hear that much.
Mm-hmm.
What's the market there? I assume you know it because obviously the potential market, it is just humongous.
Yeah, yeah. China is a big market indeed. You are correct. And because China has a lot of factories, right? The factories are producing a lot of containers. I mean, I think more than half of the containers in the world was produced by the CIMC, a company in
Mm-hmm.
China.
Mm-hmm.
And that's why when we apply to the logistics supply chain, the best way for us is to go into the factory and apply to the containers before they launch to their end user.
Yeah,
So
yeah.
in China, we actually focus the application more on the pre-manufacturing sectors that we apply to the devices during the
Mm-hmm.
factory. Like for example, in Hong Kong, we apply our materials on the surface of the 5G base station or the data center because during the usage of the data center, it generates heat, and then we reduce the heat dissipate. I mean, we use the heat dissipation to keep the performance in a high efficiency of the equipment. But in the China, the more effective way is that we just go inside the factory and apply to the 5G base station or data center during the manufacturing. I mean, when they manufacture the shell or the external surface of the devices, we apply inside, and I mean, we apply during the supply chain. And then when they deliver the containers, the container itself has been equipped with our cooling technology. Then it is not necessary for us to send our workers to the on-site, I mean, to the site
Mm,
and do some on-site job because the manpower is quite expensive in Hong Kong or some other developed countries.
yeah.
That's why in China we focus more on uh, bringing our
At the
technology inside the
origin.
factory to some
Yeah.
other industries.
And
Yes.
what's stopping you to go to Neo or Xpeng and other EV manufacturers and say, take a look at this. It could help to reduce
Yeah.
the energy
Yeah.
load.
Actually, yeah.
Yeah,
Yeah.
that
Yeah.
could
Yeah.
help
Yeah.
with the range
We're also going
extension.
into industry.
Yeah, yeah.
Yeah. Yeah. Yeah. Yeah, we are actually also going inside this as well. China
There you go.
also produce a lot of vehicles. Yeah.
Yeah,
We have done one case with a manufacturer in China. Uh, the internal temperature of the vehicles can be reduced by around 3 to 5 degrees C. And the second phase of the
that's good.
testing is about the energy reduce. I mean, to extend the driving miles, and we are on progress on that. And after successfully got getting all kind of this data, we will have a new product like this to combine our cooling technology with the vehicle's paint. But ourselves couldn't produce the vehicle paint because the standard is quite high. It is oil based for most of the vehicles paint, and I
Okay.
mean the standard like the industrial standards are quite high. So what we do is actually we provide our core materials like the concentrated liquid to the car paint manufacturer, and then we combine with their paint and then to supply to the EV manufacturer.
Uh,
That's what we are doing now in China.
what about the film? Sorry, now that you know that there is the
Yeah,
car wrapping, that it is very popular because it takes for second-hand paint, not for, let's say, production line paint. But it is much
yeah,
quicker and in theory should be also less expensive. You said that you develop a
yeah,
film.
yeah.
What's stopping you to do a film reflecting for cars?
Oh,
Did I
we
just
have
give
the
you an
plan to
idea?
do it, but
Did I just give you an idea?
yeah, not yet started. Yeah, Because this is correct. Film is a more convenient way, but film is most likely to be sold in a 4S shop, which is the B2C market.
Yeah,
And
yeah,
for the car manufacturer, if we want to do the B2B in a larger scale, they only accept the paint.
the
I mean,
paint.
during the manufacturing.
Yeah, yeah, that
Yeah.
would be more
So
retail market. Yeah,
because nowadays our team is only focusing on the B2B
yeah,
sectors, and
yeah.
but now we are expanding our team. So
Yeah.
in the next year, we will have our B2C team that can
Okay.
do some product that face to the direct end users, like what you mentioned, the car film, and
Mm,
also the umbrella, and also the cold frame, everything you can imagine that they can adopt with the cooling principles in the daily life. So
fantastic.
in the next year, we will have our team for B2C.
Bravo, Martin. Well done. This it is exciting to see all of this coming out. I really
Thank
like
you.
it. I really like it. You know why? It is also the application part. It is something that it is simple. It is not non-invasive. All right. You don't need to get author in theory. I think you don't need to get
Mm.
authorization from the municipality to like a building permit or
Mm.
anything to be able to save so much and generate so much more efficiency. So it is fascinating, my side, and like I said,
Thank you.
I really hope that you guys are going to expand, and I'm pretty sure you will continue to expand also to other countries. What I wanted to ask you it is now we both know Hong Kong, and we both know Hong Kong as being a fantastic place to do business. You have very slim bureaucracy. The city it is, let's say, set up to be able to make easy business. Okay, so the businessman, the entrepreneur, the managers can focus on actually grow the business with the specific regard though
Mm.
of policies. Okay, and with again
Mhm.
with
Mhm.
regard of energy efficiency and green tax, I don't see that much coming out from Hong Kong, to be honest. Little
Mm.
stuff. So, what do you think it could be a help for entrepreneurs like you and other entrepreneurs? I also met other guys that they trying to bring just a simple solar power plant to Hong Kong, but it is very, very difficult because you have that duopoly.
Oh,
Uh,
really?
well, it is a
Oh,
difficult thing to do. Just the connection part. Okay, the connection part it is difficult everywhere, but to be
okay.
able to set up just be a solar installer, it is not that easy. Okay, what I think,
Mm.
and then I would like to know what you think about it. It is that
Mm.
in this case, a very good help would be not to you. To the technology bring the person that bring the technology, the company that brings the technology, but it would be good to help the utilizer of the technology, that it is
Mm.
actually in one way or
Yeah.
another it is investing in your technology. Let's say that
Yeah.
you do a commercial center in Hong Kong. It would be good to have
Mhm.
a help in the form of an incentive fee or a tax rebate uh, for that company that actually generates some reduction
Yeah.
in emissions by
Yeah.
utilizing your technology,
Yeah.
uh, help from the
Yeah.
government. You got what I mean. So uh, I don't know
Yeah. I got
what
what
do
you
you
mean.
think. What do you think it would be a good help to have that super
Mm.
fast acceleration
Mm.
in the adoption of
Mhm.
technologies like yours
Yeah.
in Hong Kong, but not only.
Actually, Hong Kong has this kind of incentives, but not from the government, but from the electricity supply company. Like
Okay,
in the Kowloon side, it's CLP, and in the Hong Kong Island, it's Hong Kong Electric.
Hong Kong
These
Electric.
two companies they
Yeah.
have a scheme called Eco Building Fund. This funding can be used for the building owners to do some reimbursement if they adopt some technology that can reduce the energy cost. Each building, they can do the reimbursement up to 500,000 Hong Kong dollars. So it's quite enough if building owners they want to do some renovations to replace the old equipment or replace the old low efficiency equipment or apply with our materials. Of course, we can fit the category because we
Okay.
can reduce the energy. So yeah, because Hong Kong is, the government is, the style of the government is quite close to the British one
Mm-hmm.
because of history issue. So the government, they won't participate directly in the market. So that
Mm-mm.
but they will have a very good policy to provide a direction. For example, the electricity company in Hong Kong is actually a kind of government-funded company, a
Yeah.
kind of.
Yeah.
So that's why they will provide this funding scheme to ask their users to, oh, you need to use less electricity.
Mm.
The electricity is their revenue income, but they still provide this kind of funding, like the eco building fund, as I mentioned, to ask their users, oh, please consume less electricity. Yeah, this is the incentive part. I think if your friend or your if the friends of your audience, everyone here, if you are promoting the energy friendly technology that can reduce the building energy consumption, then you can ask your customer in Hong Kong to stay tuned on this funding. I mean, you can just Google eco building fund, and you can find the details like how to apply and also how to fill in the data to submit to the company for reimbursement. And the second one is that Hong Kong actually provide very good ecosystem for the startup companies
That's
to
true. Yeah.
establish their business here. Like
Yeah.
the Hong Kong Science and Technology Park or the Cyberport, they have the incubation scheme, they have the Stephen scheme
Yeah.
for those companies to establish here. The company, they can get some fundings, like for example, the incubation scheme in the Hong Kong Science Park, they can get around 1 million Hong Kong dollars fund for establishment, and also they can get a 3 year very good discount to the office renting fee, and also they can
That's
get
great.
four
Yeah.
manpower. That is called Research Talent Hub. That can do the reimbursement for the manpower fee from the government. The Innovation and Technology Council, a part of the funding of the government, and for the Hong Kong Science Technology Park, as I know, they have a sector that focus on the green technology. So for those people who are doing the green tech, they want to enter the market of Hong Kong. If they are willing to put a part of the R&D elements inside Hong Kong, they can apply for this funding to
Fantastic.
help the business promotion. Yeah,
That's
because
good.
Hong Kong is actually not just Hong Kong. Hong Kong is quite close to the mainland China, as you have been in Hong
Yeah.
Kong for so long, and
Yeah.
Hong Kong is the gate to the Greater China and also the gate to Asia. So
Yeah.
if you want to tackle the policy benefits from the China or from the Southeast Asia, you can go into Hong Kong first, and then you can have a lot of connections because the Hong Kong Science Park and also the Cyberport ecosystem, they are very well connected in the global market
They are. They're
with
fantastic.
different
Both of
people.
them.
Yeah,
Yeah. Yeah.
yeah,
They're fantastic. I've seen some other
yeah,
companies that they are being incubated in both
yeah,
Cyberport and the Science
yeah,
Park, and it's pretty phenomenal. Look, I think this is
yeah,
a wonderful opportunity for Hong Kong
yeah,
to
yeah, yeah.
develop that R&D, to become that R&D
Yeah.
powerhouse on not just green techs but also on other technologies.
Also other tech. Yeah, yeah,
Yeah,
yeah,
on also other
yeah,
technologies. Yeah, that's fantastic. Thank you for sharing
yeah,
that, Martin. That was very interesting, and I hope that anybody that is willing to put some effort into develop some new fantastic technologies can get some help from what you just said. So again, thank you for sharing this. I think that we have been covering quite a few things. It is very very interesting, everything you said, Martin. Your tech, it is fantastic. I was very looking forward to have you on this episode. Besides being both
Thank you.
alumni, and for the love that we both have for the School of Energy Environment, it was
Mm,
good to hear your story, and what brought you to what you guys are doing today, your journey. So thank you for that.
thank you. Thank you.
I look forward
Yeah, thank you, Francisco,
to
for inviting
have you again on board. Maybe we will talk about your next tech that you and your other co-founders are in the lab
me.
right now.
Yeah.
Okay. You give me the exclusivity, yeah. All right, be good to me.
Yeah, yeah.
Okay.
Definitely. Yeah.
Wonderful. Thank you, Martin, and take care.
Thank you. Yeah. Thank you. Thank you.
Ciao. Bye.
Yeah. Okay. Bye.
Thank you for joining us on this episode of Raw Green, brought to you by Obi, a sustainability consultancy firm specialized in life cycle assessment and decarbonization strategies. If you're looking to make an impact, a tangible and measurable one, reach out to us on our website at oneob.com or visit our social media. Links below in the description. See you at the next episode. Ciao.